All right, good afternoon, everyone. Thanks for joining Orchestration and Containerization for Atlassian Data Center. My name is David Grizzell from Trundl, the Director of Engineering and Infrastructure Services. I want to thank you all for joining. This is going to be a little bit more of a technical conversation that revolves around Atlassian Data Center. We're going to talk a bit about the architecture for the Atlassian on-prem products, and then talk about containerization tools, orchestration tools, how we've seen those implemented well, and then talk about the risks and benefits of using those. The total presentation will be about 30 minutes, and then we'll leave plenty of time for you all to ask questions. I want to apologize up front. I picked up a cold a couple of weeks back, and so I've been struggling with a cough. So if you see me popping cough drops or muting occasionally to cough, it's because I'm trying to avoid you guys having to listen to that as we go through this. But with that, let's go ahead and get started here. So in order to really understand, before we get to the nitty-gritty of actual containerization and orchestration, it's really important to understand what Atlassian Data Center is, what it's not, and how the architecture of that tool actually works. Atlassian Data Center used to be referred to as the Atlassian Server product. So if you're familiar with Jira Server, Confluence Server, Bitbucket Server, Atlassian Data Center today is really just a rebrand of that same on-prem product with a few additional features. So you probably remember, a few years back, Atlassian was really driving folks to move to the cloud because the server product was going to be sunset. And I believe Server has since actually already been sunset. I don't think they're actually renewing licenses for it anymore. A lot of folks did make that migration to the cloud, but the ones that chose to remain on-prem and continue to get support elected to go with this data center license product. The change from server to data center is at its core really just a change in the type of license, but you do unlock a lot of new features and functions and things that help you with performance and managing really large-scale implementations by being on data center. It's important to note, though, so now that we have the Atlassian Cloud versions of all of these products and then the Atlassian Data Center versions of all these products, there are distinct differences. They do have different features. So if you were to log on to Jira Cloud, for example, and then log on to a Jira Data Center that's running the latest version, you're going to see things both from a look and feel perspective and an actual feature and function perspective that are different about the two. Generally, the cloud is a little bit farther ahead of data center. That's because of the controlled nature of cloud. It's much easier for Atlassian to introduce new features in a rapid way without introducing any new issues or bugs that might affect users. It's also much easier for them to roll those changes back. Whereas if you have a product like Data Center where you're asking folks to upgrade on their own on a regular basis, maybe it's a really high volume system, you have to introduce changes in a much more controlled manner without affecting their ability to use the tool. But one benefit that Data Center offers you over the cloud product is additional control and customization. So obviously, since you're hosting the code and it's on your servers, there are certain things you can do that allow you to make it unique to your company or your use case. Additionally, there's some security controls that you get with on-prem or data center that you don't get with the cloud. And that's that you can actually enclose the data center tool within your firewall and close it off completely from the public internet. So you could set it up such that only folks that are on your network using VPN can even reach your tools. That's very appealing to certain industries and companies, especially those that may be in the healthcare sector or defense sector, where security is one of the highest priorities that they have for any of these tools. So that's a bit about data center and just kind of explain the difference between what it is and versus the cloud, which you may be more familiar with. So let's talk a little about what the architecture of an Atlassian Data Center app actually looks like. This diagram actually just shows a very basic what we call a single node or single application server deployment of Jira Data Center, for example. In this use case, your user is just accessing from your network to an application server which is referencing a single database. In some cases, that database may even be on the exact same server as the application, in which case it's just an application in a box, if you will. This is what the older Jira Server, Confluence Server license type afforded you, was just this very simple distributed architecture for your applications. The more advanced or mature version of that, and what the data center license actually affords you, is a clustered application server deployment. So from the network level, everything's the same, but now you have the ability and features to implement a load balancer with one or more nodes actually handling all of that traffic and the application load itself. We've seen as few as 2, of course, all the way up to 20 or more application servers handling really large loads for applications like Jira and Confluence. And then, of course, you still have to have a single database. So you'll have a shared database that's used by all those servers, and a single shared file system that's also used by all those servers. When you have a cluster of this size, it also affords you the ability to do things like traffic shaping. So if you want to dedicate certain portions of the cluster to handle things like API traffic or analytics traffic or maybe easy BI deployment, you can do that using this data center model. And so I want to also call out, because it's important as we go into this conversation, that there does have to be one database. We talk about the shared database. That's where all of those, in the case of Jira, for example, all of the issue field data that you fill out. So if you create a Jira issue and you're filling out the summary and the description, those form fields get stored inside of the one database. Then the shared file system is where any files that you attach, I'm still using Jira as an example, any files that you attach get stored for all of the nodes to use. So it's one big storage volume, all the application servers connect to it, and so if you, say, attach a picture to a Jira issue, it gets stored in that shared file system for all of the nodes, all the application servers in that cluster to access. So understanding a bit about the architecture, without containerization or orchestration tools, I tried to come up with a reasonable level of effort estimate for what it takes to actually deploy something like this. With the assumption that, first of all, that you know what you're doing or have some expertise or experience in doing this, and also that you have all the privileges and access to make it happen, right? So given those assumptions, as you can see by what I have on the slide here, that's really almost a whole day's work just to deploy a greenfield instance of Jira or Confluence, for example, in a small cluster with no unique requirements, no data to be migrated or anything like that. That's about how much time it would take to do all of this in a manual way. So as you can imagine, that's quite a bit of time, and you can even multiply this by, first of all, the number of Atlassian Data Center applications you may have. So this would just be for Jira, but if you also are running Confluence, Bitbucket, Bamboo, Fisheye Crucible, each of those is going to take its own set of infrastructure and time in order to deploy. And then even beyond that, if you were to need to have a test environment, for example, to test a migration or to test an upgrade, building out that layer also would just multiply times 2 or by however many additional environments that you need. So something like this can grow from a one-day project into many weeks or months of work, depending on your specific needs at your company. And in addition to that, many larger organizations, when you start talking about making changes to load balancers or working with multiple databases, it may not just be one person that's involved. You may have to have a DBA team involved applying their standards, or a networking and security team to look at how your load balancer is configured. So additional people, additional resources, this can really be a time-consuming effort to both create these environments, manage them, and then make changes to them as the company becomes agile and has additional things that they need to implement. So the solution that we have here is twofold. There is a containerization element. A container is really just bundling all of the code and the dependencies, like libraries that were related to a particular application, into a nice, neat image that you can use to very quickly deploy that. So in this case, Atlassian actually makes it pretty easy for us. They have an official Docker repository. Docker is just the name of the containerization tool, where you can log on and actually access the latest versions of all of the applications that you see on the slide, and they're the actual Docker image to download and then deploy. So that's Jira software all the way down to Fisheye Crucible and Crowd. Although it's worth noting that Fisheye Crucible is really just in a maintenance mode. You don't really see new releases there. And it's not actually data center compatible in that it can be clustered into multiple nodes. But all the other applications that you see fully support that. And we see very, very large deployments with customers using all of those. So we have our container from Docker, provided by Atlassian. But then you need to actually be able to take that and deploy it using orchestration. So in this case, we use a tool called Kubernetes, or K8 for short. And what Kubernetes actually lets you do is rapidly deploy. So instead of manually going in and creating each server and creating all the storage volumes and Linux installations, using Kubernetes in a chart called a Helm chart from Atlassian, you're actually able to very quickly do these deployments, execute upgrades, and even do scaling of the cluster in a horizontal manner just by running basic commands and rolling out that Helm chart. Atlassian also provides a very robust user guide on how to use those Helm charts along with Kubernetes to execute these. And what you'll find is that something as simple as an upgrade is a very good example. The Helm chart will let you just run a single line command, and it will then run through the process itself of bringing down the application, running the upgrade, and bringing it back up, including reapplying any customizations that you had on your original deployment. So if you're very familiar with doing an upgrade, for example, on Jira, you'll know that that's music to a lot of folks' ears, because even a very basic patched upgrade will usually overwrite customizations you make to an environment. Things like the amount of Java memory you need, or what your network settings look like, DNS names, things like that. All of that can be done through the provided Helm charts in a very, very rapid way. So, and a tidbit, so if anybody can name what venue that is in that picture, when we get to the Q&A, I'll have a special prize for you guys. So we have our containers from Docker, and we know that we can use Kubernetes and the Helm charts provided by Atlassian to stand up these environments and manage them. But it's important to note there are specific platforms that are supported when we're trying to use these tools for managing data center. At the database level, I've listed out the databases that are supported. This is pretty much in line with all the major databases that enterprise applications use today. Postgres really kind of being the favored one. That's what Atlassian uses in the back end for their cloud products. So if you have a Jira Cloud, it's using a Postgres database as a service in the background. It also supports some cluster database tools that are specific to the cloud platform that you use. So those would be Azure, as well as Amazon Web Services Aurora, which is actually Postgres based. Sorry about that, guys. I went on mute to cough and then realized I didn't get off mute. But wanted to talk about the Kubernetes platform. So basically, each cloud provider has its own Kubernetes service that you would leverage. So this is where the Helm charts would be put into play, and then you would do a lot of that administration. So Amazon's Kubernetes service is called EKS, or Elastic Kubernetes Service. Azure, same, Azure Kubernetes Service. These are all very original names, of course. And then Google's is Google's Kubernetes engine. So those are the three officially listed supported Kubernetes platforms for Atlassian Data Center. For containerization, it really is just Docker. As we talked about earlier, those are the images provided by Atlassian on their page. But I did want to note that there were prior attempts to use to provide support for containerization. One was through a tool called Amazon Web Services Quick Start. And if you ever went to download Jira, for example, then you may have actually seen it prompted you, hey, would you like to try the Amazon Web Services Quick Start image? Those were essentially CloudFormation templates that were quick deploys that you then went in and customized manually. It did save you some time, but it's nowhere near as robust as using Docker with Kubernetes. And you probably noticed from the footnote there, Atlassian is planning to do away with supporting these in the future. Officially, AWS Quick Start will end support at the end of February. There is no defined date for Azure Resource Manager template containers, but the reality is that that's probably also going away around the same time as Quick Start. It's very clear that Atlassian is moving in the direction of these Docker containers, Docker images for supporting this. Then, of course, operating systems, all flavors of Linux, Windows, and Mac. So a quick look at the architecture once we've actually deployed one of these data center apps using Docker and Kubernetes. Basically, your flow looks very similar to what it did before, except that now everything on the right side that you see in the blue dashed line where it says Kubernetes resources provisioned via Helm charts, all of that's actually managed by the Helm chart. So instead of, say, logging onto a server and updating a configuration file to address a change like changing memory, you're now making those changes in the Helm chart and then executing the change. And then it's all kind of self-managed from that point forward. It may shut down a server. In this case, Kubernetes language, they call it a pod. They shut down the pod, apply the change, and then bring it back up. But there is still a small segment that's worth noting where you do manage things manually. That's that gray section that you see to the left on the slide under the cloud provider section. So those pieces you would still manage on your own, and you'll kind of want to, because those are the areas that are usually a bit agnostic from the application itself. So that's the load balancer, which gives you the power to manage the networking and security rules. That shared database that we talked about, the shared file system where the attachments are stored that we also talked about. And then in the case of Bitbucket, there's one unique service called Elasticsearch that you would also have to manage on your own as well. Kubernetes does not cover that. Elasticsearch is really just what it sounds like. It's the search mechanism behind Bitbucket because the source control repositories are so large and there's so much code in Bitbucket, you actually need a separate service to constantly do that indexing and permit searches across all of your code base. So that piece is actually continues to be managed on your own, but everything else that you see on the right is now managed through those Helm charts. So let's talk about what the real pros and cons of this approach are versus the manual piece, or the older manual way of doing things, I should say. Some classic memes on these slides for you too. So the real benefits of using Kubernetes and Docker, the biggest one, after doing this for several years now, is really the ease of right sizing. So with every single data center deployment that we work with, regardless of the size of the company and how many users they have, whether it's tens of thousands or 5, it always comes down to trying to balance really good performance and a good end user experience with how much you're paying to maintain that performance. And so a lot of times what we see is that you may elect to have 10 servers dedicated to running your Jira instance because you have 10,000 users in your Jira at lunchtime. But then at midnight, there's literally no one inside of Jira. And so you still have 10 servers that you're paying for to handle that traffic. So because these Helm charts and the use of Kubernetes allows us to do that horizontal scaling in real time, we're now able to leverage the on-demand cost that providers like Amazon provide to make sure that cluster is always at the exact right sweet spot, right? So I call it the Goldilocks zone. It may be however many nodes you need at that exact time that scales up and down, as needed. We didn't really have that under the manual method. You usually would have to manually go in and add a node if you needed to, and then go through a deprovisioning process if you wanted to take one down. Even tools like Amazon's EC2 autoscaling weren't really supported or possible to use with these tools until we now have Kubernetes to work with. So that's a huge one because it helps us save costs, but also ensures that the performance needs are also being met. Similarly with test environments. So if you have a large data center environment and you're planning to do a major upgrade, you're usually running some kind of non-production environment to do those upgrade tests against. Because of the effort that it takes to manually do a build, which we talked about earlier, it could be potentially weeks, you don't want to tear that down and rebuild it every time you need to do an upgrade. Well, because of the ease of doing deployments now with these containers and Kubernetes combined, it's much more feasible to say, we're just going to run production, and then we're going to deploy an environment on an as-needed basis to handle things like upgrades or testing integrations or any other, migrations, anything else that you might need to use a test environment for. Again, this is a tremendous cost savings. You could imagine a non-production environment running all the time, and then now you only have it actually running, maybe a few hours a month. That's quite a reduction in a otherwise potentially very large Amazon Web Services bill. So that's probably the biggest benefit. The other two pieces are just that manageability is big in reducing overhead. So again, very low effort upgrades, not as much touch that's required to do either testing or the actual production upgrades. Same with rollbacks, they're just as easy using the Helm charts. And then also just the agility in the configuration. So, as your security team comes to you or your networking team comes to you and they have new requirements or new standards that they want to see implemented for your data center tools, the ability to very just quickly and in an agile way go in and test those changes and implement them, again, dramatically reduces your overhead. Something that used to be a project is really now just maybe a day of testing and validation and implementation. But of course, it can't always be in benefits. There's always risks to anything, two sides to every story, right? So some of the risks to the Kubernetes and Docker approach, the first is that it really is not technically supported by Atlassian. So even though they do provide the Docker images, and if you go out there, you'll see they're out there providing updates constantly. Even though they do provide the Docker images and the Helm charts, they're also very receptive to feedback. They don't technically support it, meaning if you run into an issue that's specific to leveraging these tools, problem with Docker, problem with Kubernetes, and you reach out to support, they're not necessarily required to provide you support with those pieces of it. Now, I will say many a times they will still make a best effort to do so, but they don't technically, cover that. So you just have to know that going in, that you're a little bit of a pioneer, and there may be some Googling and troubleshooting or working with an Atlassian partner to try and address any issues that you run into. Another risk is that this is, and this comes with any new thing that's in the market, right, is that as a new asset, it may contain bugs. You're a little bit on the bleeding edge. Even as recently as last week, excuse me, as recently as last week, we even uncovered a bug with the Helm chart configuration as it relates to user management, user ownership on the Linux platform. We presented that to Atlassian, they acknowledged it, and I've already seen an enhancement, in the public domain showing that it's something that they're going to work on addressing for us. So just know that you may run into things like that, but again, that comes with the territory, and it's certainly something that Atlassian and a partner will work with you to overcome and address, permanently. And the last piece, and this really is something specific to very large enterprises, is that this sort of managed approach using containerization and orchestration does not really account for robust disaster recovery setups. The reason for that is, and I'll give you an example, is we have some customers where Jira is a mission critical application. If there is a disaster, they're relying on Jira to help them recover, so it cannot be down. In those cases, we do things like set up what we call a hot standby, usually in an entirely different geographic region, that's getting live replication of the database, the storage, everything. That's ready to turn on at a moment's notice, and it'll be up to date and ready to go as the new Jira environment. This type of setup doesn't really support that because it's across many regions, obviously, but also because some of the configurations in the Helm chart and aspects of the Docker image don't really support setting up and validating that replication is there. So if you have this type of requirement, you could still leverage these tools. You'll just have to know that you have this additional step of manually ensuring that your DR is still there and ready to go, and that the replication is working as it should. But that's an important thing to call out since with the Atlassian Data Center tools, you're really responsible for the backup and recovery aspect of the applications, whereas that's not really the case when it comes to the cloud because you don't own the back end. So that's really it in a nutshell. I wanted to also share with you these resources. Please feel free to screenshot this, and I'm sure we can make the links available to you all. But we wanted to really kind of talk through what the tools are that are involved, what's supported, what's not, where the Atlassian resources are, so that if you have an interest in this, you can begin doing some sandboxing, on your own to potentially implement this. So I also wanted to make sure that we had plenty of time to, have some questions. We can deep dive with some technical topics if we want to. I know we also have some other Trundle team members on the group on the call here who could potentially also help answer questions too. So with that, I will jump to the Q&A, and we'll start with the written questions here. So Eshwar asks, can we switch user session between different nodes as a Jira admin in the cluster to troubleshoot an issue with a specific node? So that's a good question. That really is not something that Kubernetes would handle, right? So what Eshwar is asking is, in a cluster on Data Center, maybe I have an issue that I think is specific to one particular server. In a traditional model, the load balancer is deciding where you're going to go. And you don't actually know which node you're going to. It's just doing it based on volume, which server is providing a healthy response or not. So in order to, for the user to say, hey, I want to make sure I connect to this node on the back-end pool, there's nothing in Kubernetes that would permit that. And really, I would expect it to. That's really more of a function of being able to bypass the load balancer. So that's why that's something that could potentially be accomplished elsewhere, through some testing and configuration changes at the load balancer level. Good question, though. So next question, Daniel asks, can multi-node and load balancers be implemented after an initial migration? Yeah, so you could, if you wanted to basically, so the way that would be controlled, Daniel, is through the Helm chart. You would basically just define that it was, a single node for your initial migration, and that, there is no load balancer or proxy to be concerned with. It would do its deployment, and then when you're ready to implement a load balancer and additional nodes in the cluster, you'd make those changes to the Helm chart and then do your push, do your redeployment. Now, of course, you certainly want to test that before you just made that kind of fundamental structural change in production, but it's totally feasible that you could start small and then build once you've made your shift to these tools. Very good question. I'm sorry, Daniel Alonso had a question at the top and I missed that. So Daniel asks, can you deploy a single node in an instance that is already running? So the scenario would be one of your nodes gets corrupted and you need to restore it in a new node. So that's really more of a matter of migration. So you could use this to deploy an additional adjacent or parallel Jira instance or whatever the data center tool may be. But then it would still be on you to make sure that you migrated to handle the recovery, right? It also kind of depends on why you're trying to recover. So if the corruption is happening at the database, then you might be in a tougher spot, trying to recover that database since it can only be one. But if the issue is with a specific application server, then yeah, this could potentially help you with recovering from that, since you can have as many application servers as you need. Yep, good question. These are all very good. What else do we have? Any other questions that I can answer for you guys, or other areas that you want me to dive in a little bit deeper? Did anyone know what the venue was on the orchestration page? All right. I think we got all of the questions then. All right. Well, thank you guys.
Hey, David, I thought I would just take this time to ask a question since we have another few minutes. So, are there any top, few things that folks need to keep in mind when moving from those traditional environments like, hypervisors or VMware worlds to kind of, moving towards this orchestration using, Docker and Kubernetes?
Yeah, I think I would say the biggest thing is going to be the risk that I highlighted on the risk page, right? So, um, just knowing that you don't necessarily have the same level of support, if you're going to make this move, you're kind of being a pioneer. So be prepared to do some of your own troubleshooting. As you test this out, leverage a partner or Atlassian partner if you need to. That's really the biggest thing. Beyond that, the administration and upgrades and things like that, the user guides are all very helpful. So I think you'll find that that's going to be quite a bit easier for you to handle than doing it the manual way. But yeah, that's the biggest thing is just understanding, what parts supported, what parts not, and where you may need some help.
Got it. All right, that's all. I think we don't have any more questions. Okay, Daniel has another question.
Sure. Daniel asked Detroit Orchestra Hall. No, I'm afraid not. It is in the U.S. That's actually the Schermerhorn Symphony Center in Nashville, Tennessee. Good guess, though.
Any more questions? Can I give a couple minutes here, David, or do you want to kind of talk about any of our experiences that we had with Trundle customers moving towards this journey?
Excuse me. I'm trying to think if there's any specific use cases I can talk about. We did recently do this for a very large healthcare customer. So they have been using manual deployments for a very long time on-prem on their own servers, and had a lot of trouble actually even trying to get a cluster stood up, just because of the level of effort that it takes to manage that manually, and because doing things with on-prem servers can just be really challenging. So we actually migrated them to Amazon Web Services first, kind of using the manual method just to get them off of the on-prem data center. And then we are now in the process of shifting them over to this Kubernetes and Docker-based system. And it's been amazing because doing those manual upgrades for them would require easily, I would say, 40 to 60 hours of intense work from subject matter experts that do that day in and day out. Whereas now on this new system, using the Helm charts to do those upgrades really just takes, maybe 10 minutes to execute, just do some validation and then do it in production. So the time savings is very, very, very intense.
Absolutely. I think, the front loading all those efforts would help down the lane, make it easy.
Yeah, definitely.
Just making sure that, okay, there is one more question from Ishwar. Let me just pull it onto the screen. There you go.
So Eshwar asked, how can a Jira admin help to set up an Atlassian data center when a different team is working on the infrastructure setup? That's a good question. So you really have to think about what are the kind of questions that the infrastructure team is going to be asking you, right? They may need to know, they're going to be looking at questions about how many resources should I apply, right? How much compute do we need? How much memory do we need? And so as an administrator, you're going to have visibility into certain statistics about that data center instance, right? How many users are there? How many projects are there in the Jira instance? How many workflows? You can look at some of that information about how big or how much volume you expect, and then translate that into the resources for the infrastructure team member to properly size the Kubernetes pods, or in the case of a manual deployment, the server itself. And if you're having trouble kind of doing that math or doing the formula on figuring out what that looks like based on the number of workflows, Atlassian makes a page available in their documentation publicly, where they even give you the general sizing guide. So it'll say if you have this many users and this many workflows, you probably need 8 gigs of RAM and 2 CPU. And so they provide that all the way down to enterprise grade instances. And they even have that same guide, but specific to the AWS world, where they'll say, okay, this type of EC2 instance needs to be deployed for this many users. So that's the kind of thing a Jira administrator has that access to that information, can easily, do that sort of crosswalk, and then, let the infrastructure team know what those requirements will look like. That'll make things much easier for the infrastructure team. Good question, Eshwar. What else can I answer for you guys? Anything?
I can think of one, like, given so many options that are out there with regards to the public cloud, right? So is there any preference of, trying out these new way of deploying things on one versus the other?
Yeah, that's a good question. So, I mean, technically, the supported platforms are going to be Google, Azure, and Amazon. Between the three, it kind of depends on where your priorities are as to which one you would want to choose. So, for example, if you're already very invested in the Azure, space, then you're probably going to want to just go with the Azure Kubernetes service for deploying this. If you're coming in sort of green with no loyalty to any of the cloud providers, our recommendation as Trundle is probably going to be Amazon Web Services. The main reason there is that their product is generally seen as the most mature. They've been in the game for a long time. We find that their Kubernetes interface is very easy to work with. And then the biggest thing is that their costs are just almost always the most competitive in terms of how much you're paying per hour, per day for these resources. So we would lean towards Amazon, but of course you've got to look at each of your unique use cases to determine which vendor is the right fit for you.
Got it. Thank you. Ishwar has another question. Let me just bring it onto the screen. There you go. When there is a need to handle more traffic or number of requests with existing data center, should we increase the hardware config of our setup or add more nodes?
Very good question. So generally, in the old world where it was manual, we would actually probably default to just trying to increase the resources on the node, because it was easier than trying to add a new node to the cluster. Now that adding or scaling horizontally is so much easier, it can basically be done with just a few clicks. We would now default towards, okay, we need to increase the scale, right? So just add an additional node to handle the traffic while it's occurring, and then allow it to scale down on its own when it's no longer occurring. So, yeah, good question. This goes back to that right sizing aspect of just enabling the Kubernetes pods to expand as they need to cover what's going on, and then reduce once it's no longer occurring, as opposed to just adding memory that's probably going to be unused in the middle of the night when that increase in volume is no longer occurring.
All right. All right. So if you have any more follow-up questions, do join David and his team, in one of the rooms that we have open for you guys to come and talk. So absolutely, thank you very much all for joining in here, and hope you will continue to take advantage of the next sessions that are lined up. Thank you, guys. Thank you, David.
Thank you all.